Hi there, Mr. Sutton here with the Pre-Cal Honors 7-3 Part 1 homework solutions on parametric equations. For number 1, we're trying to find vector and parametric equations for a line through -3, 0 with this direction vector. So in general, we want the initial point plus t times the direction vector for the vector equation. So let's just do that. And then for the parametric equation, we're going to just use the x stuff and the y stuff separately. So we have x equals -3 minus 4t, and y equals 0 plus 7t, which we can just write as 7t. For number 2, we want a vector equation in parametrics for the line going through this point with this direction vector. So we're just going to have x comma y equals the initial point, which is this -3 comma -8, plus t times the direction vector, which is this stuff over here. And then we just have for the parametrics, x equals -3 plus 12t, just using the x components, and y equals -8 plus 1t, or just t. For this problem, we want a vector in parametric equations for a line that has an x-intercept of 4 and a y-intercept of -8. Let's start by first translating what this really means. So if we have an x-intercept of 4, that means you have the point 4, 0. Y-intercept of -8 is the point 0, -8. So these are what we're really dealing with here. And so this is really just that situation where you have 2 points. So we need to create a direction vector using these 2 points. And we'll assume that this x-intercept is our first point here. So we're going to have 0, minus 4, comma, -8 minus 0 for that direction vector, which gives us the direction vector -4, -8. So now to write the vector equation, we just have our initial point, 4, 0, plus t times this direction vector. And now to write the parametric equations, we have x equals the x value of the initial point, 4, plus 4 times -t, or 4 minus 4t if we want to simplify that a little bit. And then for the y parametric equation, we have y equals 0 plus t times -8, or just simply y equals -8t. For number 4, we want a vector equation for the line with these 2 points in it. To get the direction vector out of this, we need to find the component form. So we've got 3 minus 1 and -4 minus 0. So that gives us a direction vector then of 2, -4. A vector equation will just be the starting point, which we'll just use the first of these points. So 1, 0 plus t times this direction vector. All that equals x, y. For the x parametric, we've got x equals 1 plus 2t. And for y, we have y equals 0 minus 4t, or just -4t. For number 5, we want a vector and parametric equations for a line with these 2 points in it. Let's start by getting the direction vector by using the component form. So we've got -2 minus -4, or plus 4, and 6 minus 1. So that's a direction vector of 2, 5. We have then x, y equals the initial point, -4, 1, plus t times 2, 5. For the x of the parametrics, we've got x equals -4 plus 2t. For y, we have y equals 1 plus 5t. For number 6, this one's a little trickier. We want vector and parametrics given an x-intercept of -2 and a y-intercept of 10. So they're actually giving us 2 different points here. This x-intercept is just going to be -2, 0, and this y-intercept is 0, 10. For our initial point, we'll use this x-intercept, and we'll just go in the order that they gave us the stuff. So let's get our direction vector. We need the component form for that. So that's 0 minus -2, or plus 2, and 10 minus 0. So 2, 10. For the vector equation, we've got the initial point, -2, 0, plus t times our direction vector. For writing our parametrics out now, we have x equals -2 plus 2t, and y equals 0 plus 10t, or just 10t. For this problem, we want a vector and parametric equations for a line that goes through 1, 5 and has a direction vector of 2, -1. So this is set up pretty much for us to put right into vector equation form. we've got x comma y equals starting point plus t times direction vector. So x comma y equals 1 comma 5 plus t times our direction vector of 2 comma negative 1. So that'll be our vector equation. For the parametric equations, we just take x and y separately. So for x, we have x equals 1 plus t times 2, or 2t. And then for y, we have y equals 5 plus t times negative 1, or 5 minus t. For this problem, we want a vector and parametric equations for a line that goes through these 2 points. To start us off, we have to first get a direction vector. So we've got 5 minus negative 2, or 5 plus 2, comma 1 minus 3. And that gives us the actual direction vector of 7, comma negative 2. Next, for the vector equation, we've got the starting point of negative 2, comma 3, plus the time, t, times our direction vector of 7, comma negative 2. So there's our direction vector, x comma y equals that stuff. Now for the parametrics, for x, we have x equals the starting x value of negative 2 plus t times 7, or 7t. For y, we have y equals our starting y value of 3 plus t times negative 2, or 3 minus 2t. For this problem, we want a vector and parametric equations for a line that goes through these 2 intercepts. Now, to make this a little easier, I'm going to rewrite these as actual points. So this x-intercept of 4 is really the point 4, comma 0. This y-intercept of negative 3 is really the point 0, comma negative 3. So now we just have the same situation as we had on one of our earlier problems, where you just need a direction vector based off of 2 points. So we're going to get the component form for that direction vector. That'll be 0 minus 4, comma negative 3 minus 0. So that's a direction vector of negative 4, comma negative 3. And now our vector equation, that's going to be our starting point, which will just be this first point here, 4, comma 0, plus t times our direction vector of negative 4, comma negative 3. For the x parametric equation, we have x equals our starting x value of 4 plus t times negative 4, so 4 minus 4t. And then for y, we have y equals starting x value of 0 plus t times negative 3, or just simply y equals negative 3t.